Hello, everybody. What happened today? Not many people. Can you hear me?
Yes, sir, you're audible.
Okay, so let's. Did you do the homework which I gave? Hello. Can somebody show me the solutions? We can discuss the solutions quickly and go through. I'll wind up with prologue today. All right. So the first question was reverse. How do you do reverse? You say reverse LR. So L is supposed to be the original list and R is supposed to be the reverse list. You can do it two ways. One is you can do the recursive way. This is the iterative way. So I take a third list and I say reverse helper L empty list R, and I say reverse empty list LL, which is true. Okay, if the first list is empty, then I say that the second list and the third list are the same. So that means that R will become the reverse list. And reverse XTYL, I'll take X and put it in front of Y. Okay, so that is T and X bar Y and L. Is this the solution you got? Hello? Okay, I think that was easy. Now the second question was sorted of X. X is a sorted list. How do you do that? So sorted empty list is already sorted. So that means sorted empty list dot. And a list which contains one element is also sorted. So sorted with one element X is also sorted. And then I say sorted with at least two elements. Sorted X comma Y bar T. If X is less than Y and sorted of Y bar T. So I first check the first two elements. I check if they are if they are in order, and if they are in order, so I am checking if it is in increasing order. The list is sorted in the ascending order. Okay, and if the first two elements are sorted, then I drop the first element and I carry on with the second element. Sorted by party. Okay. Next is any questions? Next was duplicate XL. Now, how do I do duplicate XL? I say duplicate X bar L. If I have a list X and X bar L, and X is the first element. Okay. In that case, I say that X has to occur once more in L. So I have a predicate which checks if X occurs in the list L. Now how do I write that? That is the predicate occurs. So occurs X bar L. X occurs in X bar L. And otherwise, if it is some other Y, then I say occurs X Y bar L if occurs X L. Okay, Y need not be the same variable. If Y is the same variable, then it is already satisfied by the first rule. Okay. So this way I can write a predicate occurs, which will check if a variable X occurs in L. if a value occurs, X occurs in L. Now that I can use to write duplicate. So duplicate X bar L will be occurs X comma L. And duplicate X Y bar L will be duplicate XL. Okay. The last one was subsequence. I have X and Y. Now I have to check X is a subsequence of Y. So I write subsequence of empty list, empty list. Okay. Now subsequence of X bar L and X bar K. In that case, I say subsequence of YL comma K. If both the lists have the same first element, then I say I have to check for subsequence in the rest of the list. Otherwise, I say subsequence L Y bar K will be subsequence LK. If it is, yeah, there I don't have to check if the what I don't have to care about what is the first element of L. Okay, I'll post it. Post it here. Okay, all right. Now let's continue with what is remaining in prologue. Okay, any questions? Any questions? All right. All right. So last time I already we started with something called negation as failure, and our motivating example is let me start a new window. NIF. Okay, I want to write a predicate max. Max S, Y, Z. And I want to say that if X is smaller than Y, then I want to say that Y is Z is same as X, Y. And now if otherwise, I want to say that X is equal to Z. Okay. Now this is problematic. Can you see why it is problematic? What is wrong with this definition of max? Any question? Any idea? Why is this definition of max problematic? Hello.
Sir,
You are not audible.
I'm not audible.
Sir, you're audible. Can you hear me, sir?
Yeah.
Okay, sir. Since y equals z and x equals z,
Yeah.
that x less than y is like a contradiction, right?
No, it's not about contradiction. I want max to behave as if X is less than Y, then Z has to be Y. Otherwise, if X is greater than Y, then Z has to be X. But I don't have any, I want to write it in prologue. And in prologue, I don't have any means of saying otherwise so far. So I wrote it this way. Now, what can go wrong? Saina, can you hear me?
Yes. Yeah.
Yeah. So what can go wrong?
So if you keep on searching for new results, then you will finally get x is equal to z. because of the DFS search.
Yeah. So what will go wrong here is this. So imagine I use this rule somewhere like max PQR. Okay, and some dot dot dot. Okay, so I have used this max in some other rule. Imagine. Now I want this max PQR to behave as if exactly like max. Yeah. So that means that if P among P and Q, if Q is bigger, then R has to be Q. But if P is bigger, then R has to be P. But now Prolog works to prove this thing, max PQR. Okay, Prolog always tries to prove something. Now, if P is less than Q, then there is no way Q has to be R. Now, imagine P is greater than Q. I mean, P is, no, if P is less than Q, and then to prove this goal, Prolog tries with y equal to Z. So that means Q with R. Now, if that one fails, then it doesn't matter whether X is less than Y. It will always take X is equal to Z. So that means P will be equal to R will be tried. And if this goal works with P with R, then regardless of X less than Y, this one will work. Does that make sense what I'm saying?
Sir, please explain again.
Yeah. So Prolog's goal is to prove this goal. Okay, I have a goal here, G1. Okay, I have a goal here, G2. Now Prolog always I give G1 as the goal for the program. Now to try to prove G1, Prolog has to prove max PQR. Now in max PQR, my idea is that if I want max to behave as if exactly like max, that means that if among PQ, the biggest should go to R. That's my idea. Okay, but this code does not work. Why? Because if P less than Q, then Q equal to R will be tried first. And if that doesn't work, if Q equal to R doesn't work, then P equal to R will be tried. Okay, so even if P is less than Q, P equal to R will be tried according to this rule. Okay, so my max does not behave as max. To prove that, to say that max behaves as its max, I have to somehow say that otherwise, if I have to say not of X less than Y. Okay, now there is no not operation in the not operation of Prolog is negation as failure. I already told you last time. Negation as failure. Okay, so that is represented as slash plus. Okay, so if I say slash plus X less than Y and X equal to Z, then the meaning of this is this. This is the following. If there is no, so I'm already when I come here already the value of Y and X are fixed. Yeah, because I'm trying to prove some X equal to Y. So here, for instance, P and Q will be given from this one. And I will try to prove, the Prolog will try to prove X less than Y. If it doesn't succeed, then slash plus X less than Y is considered to be true. Okay. In other words, slash plus X less than Y is true if X less than Y fails to prove. If Prolog fails to prove X less than Y. Okay. Is that okay? Is that clear? Hello.
So, but why there is need of that condition? Slash plus and X less than Y.
Yeah, that's what I explained. Now, if I just leave it like this, it doesn't work because it will work even in this case. If I say Y X greater than Y, if I write like this and this, there is no difference. I mean, if I just leave it like this, it will work even in the case of x less than y. That's why.
Sir, we could have written one more condition in the second one, x greater than equal to y.
Yeah, x greater than equal to y. That's a good question. But now the question, this thing is that we have not added anything more, because x greater than y is nothing but, so somebody has written x greater than y as negation plus x less than y. Okay, you understand what I'm saying? This is x greater than y is nothing but failing to prove x less than y. Okay, but in this case, in the case of numbers, Prolog has a subsystem, but not always you can negate this way. You understand what I'm saying? In this case, it so happens that the negation, the less than y, less than and greater than are negations of each other, and Prolog has already implemented that. So you could write it as x greater than y. But in cases where you have to negate a predicate, you have to say that I don't want this goal to hold true. Then there is no way, but you have to use negation as failure.
Sir, but how will we know that what is elementary? So here you took x less than y as elementary and then defined x greater than y in terms of negation of x less than y. What it could have happened the other way around, right? That we could have had x greater than y as an elementary thing, and then we could have defined x less than y as a negation of that.
Yeah.
So so
Yeah.
then how do we know that? Then first statement could be then problematic if that was not defined in that way, if someone had not written the rule.
The case is that less than is a element, is a primitive predicate. It is already implemented in Prolog. Less than and greater than. Okay. Now imagine I want you to write a predicate like simple example is I have a list. Okay. I have a list. I want to write a predicate like disjoint of L comma K. Okay, two lists are disjoint. Now, how do I write two lists are disjoint? Imagine I have a predicate like member x k if x is an element of k. Now I can write overlap L comma K. How do I write overlap of L comma K in terms of member? How do I write overlap of L comma K in terms of member? Anybody? Hello?
Overlap as in the sense like.
Yeah, X and L and K has some element overlapping. There is some element which is both in L as well as in K.
Yeah, member of Z, comma L,
Z comma L,
comma member of
Z
Z,
comma
comma
K.
L.
Yeah. Now, how do I write? Now, disjoint of L comma K is failing to prove overlap of L comma K. You agree? Member of,
Not okay.
yeah. So member X comma member function is nothing but this. Yeah, this is what member function is. Member of x comma x bar t is dot. Member of x comma underscore t underscore bar t is member of x comma t. This is what is member. Yeah. Everybody agrees with that? Hello.
So what is the base case in that member function?
Base case is x comma x bar empty list. T when t is empty. When t is empty. When t is empty list, it is x comma box x. But I don't have to write that because for any variable t, I can take it as a base case. For any value of t, I can take it to be a base case x comma x bar t. Yeah. Hello.
So, but if X is not a member of that list that we are trying to find it in, and then it becomes an empty list, then what? I'm not able to understand what will happen then. So it calls X to an empty list.
No, xt cannot be an empty list. No, whenever I get an x, I'm saying that member, in order for x to be a member of some list, x has to occur in the head, and then I don't care what is the rest of the list. If x does not occur if otherwise, x is a member of a list if I don't care what is the first member, but if x is member of the rest of the list, the tail of the list, then also x is a member of underscore bar t. That's what this definition is. I think you guys are not doing homeworks, huh? Because it's a very elementary definition. Hello. Member is clear? No?
Yes, sir, it's clear now.
Okay, so that's how I write member. Now overlap is if there is some z for which I can prove z member of zl and member of zk. Now disjoint of L comma K is actually failure to prove overlap of L comma K. So therefore I can write it as disjoint of L comma K is nothing but overlap of LK. Okay. Now this definition, there is no way I can prove, there is no way I can write disjoint without using negation as failure. Okay, it's not like in the previous case I could write x less than y and y less than x. I have automatic negations provided by Prolog, but in this case I don't have that. You know, if I want to complement a goal, then I have to use negation as failure. Okay, so what is the meaning of L comma K? Disjoint of L comma K if I fail to prove overlap of L comma K. Now, how do I succeed in overlap of L comma K? If I could prove for some z member zl and member zk. Okay. All right. Okay. Anyway, next week we will have a quiz. No, not in next week. Next class. So day after tomorrow. In the class slot, we will have a quiz on Prolog. Okay. All right. Okay. So let's continue with Prolog. Prolog cannot assert something is false. Negation as failure. Anything that cannot be proved from rules and facts is considered to be false. Hence the name negation as failure. Not that this is different than logical negation. In SWA, it is represented by the symbol /plus. /plus member XL. /plus A less than B. X not equal to Y is shorthand for /plus X equal to Y. That's what I was saying. Prolog implements one logical predicate and then the complement of that is written as slash plus the positive predicate. Okay. So this is the example which we did. So just now defining disjoint sets, overlap of S1, S2 is member X S1, member X S2. And if I want to prove disjoint S1, S2 is slash plus overlap S1, S2. Okay. Now there is now when is so there is some doubt about what happens. What is the meaning of should this? How do I ascertain the meaning of something like this? Okay, slash plus overlap of L comma K. So there are two scenarios where you can concretely say it has a definite meaning. One is when before we go into this predicate, the value of L and K is fixed. Okay. So if you have a goal like slash plus G, it works properly only in the following two cases. So what I'm saying is something like this. If I have a goal predicate X, Y, Z. Okay. Okay. Imagine I have a rule like this. Okay, I have some goal which is in slash plus some predicate X, Y, Z, and then followed by some dot dot dot. So this slash plus only applied to this goal, this predicate. Okay, so this goal will be satisfied if this goal is failed to prove and these goals fail to succeed. I mean, sorry, happen to succeed. So in this case, the meaning of this goal is not clearly defined. Okay, so we should never use slash plus in that way. Because this X is used here also. That's not a good idea. Okay, because in this case, it's not clear what should be the value of this X. Because in this case, it should fail to succeed, and here it should fail. It should happen to succeed. Okay. So when G is fully instantiated at the time of processing slash plus, in this case, the meaning is straightforward. Everybody understands what I'm saying?
Sir, I didn't get the last point.
This one?
No, sir, before that.
Slash plus G works properly.
No, sir. Sir, when you said that, that's not a good idea to use. So in one of the predicates, we had to use X for fail to prove. And in the other one, we had to use X to happen to succeed.
Yeah. So in this case, the meaning of this thing is only clear when you know what is the value of X before you go into these predicates. So if X is already given from this goal, okay, this goal already specifies what is X. Yeah. For instance, it can be a constant. In that case, it is clear what is the meaning of this X here as well as here.
Yes, sir.
Okay. That is one case in which we can definitely say this is the meaning. What is the other case? The other case is there are uninstantiated variables in G, but they do not appear elsewhere in the same clause. In this case, it means there are no instantiations for those variables that makes the goal true. Example, slash plus G of X means there is no X such that G of X succeeds. What I'm saying is that, so if X value is not definite, then it is not clear what value X should take. Because in one it should succeed, in one it should fail. Yeah. But if you don't have X here, okay, if you don't have X here, then this X could be taken to be there is no X such that this succeeds. That's exactly what we have done here. We have written disjoint of L comma K is slash plus overlap of L comma K, and overlap of L comma K is member ZL member ZK. Okay. Instead, we could also write we could also write the same rule like this. We could also write the same rule like okay. So when you do this space between this slash plus and this parenthesis, there should be a space. Okay. I could write the same rule like this. Disjoint of L comma K is member negation slash plus member ZL member ZK. And if I have some other rule, if I have some other rule here, goal here, then that ideally should not use Z. Use Z. Because if I use Z here, then that Z comes only in this clause and this Z will be repeated here. So that's not a good idea. Okay. So when you write, either Z should appear here and this value should come from here, or otherwise it should not, it should be used only in this clause. It should not appear anywhere else. Okay.
Sir, I still didn't understand why it's necessary.
Because if this goal uses Z, then it is, you can't easily read what is the meaning of that. It's not very clear. Yeah, for instance, it could happen like this. You have some value of Z for which it fails to prove, and you have some other value of Z for which it succeeds. Okay. You will understand how, when in the next setting we will see how we implement slash plus. Then you will understand. Okay. Then let's hope you will understand.
Okay, sir.
Otherwise we'll come back. Okay, so these are the two proper uses of slash plus. Yeah, one is when the values are already instantiated. The other is when the values don't overlap, the variables don't overlap between positive and negative clauses. Okay. All right. Okay, so this is the max we are talking about. Max xyz, which holds if z is the maximum of x and y. Using negation as failure, you can write max xyz as x less than or equal to y, then z equal to y. Max xyz is, otherwise you write max xyz is if you fail x less than or equal to y and z is equal to x. Okay. Now this is a simple example, but it shows a general pattern. We have two cases. You have a clause A, and you have two scenarios when A succeeds and when A fails. You want to write your goals based on these two scenarios. So in that case, you will write P is a goal which succeeds if A comma B. If A succeeds, then B, you try B. If A fails, then you try C. Okay. This is a case with max. This is a case with many other situations you will see. So there is a shorthand for P if A comma B and P not A comma C. And that is written as arrow. Okay. If A then B, L, C is written as A arrow, B semicolon C. I have already told you semicolon is like or. So you will write it as A if B or C. A if B or C. Okay. So you can write it as a, so this means that try A, if you can prove it, go on to prove B and ignore C. If A fails, however, go on to prove C, ignoring B. Okay. So let's write max using arrow. Max xyz if x less than or equal to y, arrow z equal to y, or z equal to x. So yeah. So I'm trying to prove max xyz. This is the same clause. I can write it as max xyz, x less than or equal to y, arrow, z equal to y, or z equal to x. Okay. Clear? Questions? Hello.
It's clear, sir.
All right. Not that you may need to add parentheses around A, B, or C themselves if they are not simple predicates. Yeah, when you write parentheses, you have to be careful that there has to be a space here, slash plus and space. Okay. Okay, let's do an example. Let's write set minus. Okay. List minus. I want X is in L, but not in K. Can you try and help me here? What should we write? List minus X L K. X is in L, but not in K.
Sir, so our objective is just to just true and false, or we have to if it is present in K, then we have to remove it.
No, you just have to state.
Okay.
You just have to. It's a Boolean function. Return true or false. Yeah. So I mean, somebody might ask, what is the value of K? What is the value of L? What is the value of X? See, if you have such a function, it could work in multiple ways. It could work to find out X. It could work to find out Y. I mean, find out L. It could work to find out K, and so on. Yeah, you can't. That's a specialty of Prolog. Usually in functions, you give the inputs and something comes as output. In Prolog, there is no notion of input output. You can always give some parameters, and Prolog returns true and variable bindings. Yeah. So this goal has to succeed for every variable binding X, for which X is in L and X is not in K. So how do I write? Yeah. We have already written half the stuff for this. We can write member now. Member XL, comma.
Not.
Yeah, not of member.
ZK.
XK.
XK.
Okay. Now here I can use the same X because when you come from here, X is already fixed. X is already instantiated. Okay. So that's why Uh, yeah. So if I give list minus X and 1, 2, 3 and 4, 1, 4, then I get two options. One is 2, one is 3. Okay. Let's do another example.
Hello, sir.
Yeah.
Sir, why you got x equals to 2 and x equals to 3 in that? I'm not getting.
Why? What?
Sir, you got false in the end.
Yeah. Yeah.
But why you got x equals to 2 and x equals to 3?
Because I am asking for an X which is in L1 and which is not in L2, which is in 1, 2, 3,
Oh,
but not in 4, 1, 4. So one is in L, but it is not. It is also here. So I cannot use that. 2 is here, but not here. 3 is here, but not here. That's why I got 2 and 3.
okay.
Sir, I have a doubt.
It's
11 o'clock. Yeah, so if you actually switch those member things, like if you actually write first not member of x comma k
Yeah.
and then member of x comma l,
Yeah.
whether it will create a problem or
In this case, in that case, we cannot be sure about what is the answer going to be. Okay. The answer is not obvious to us. Sometimes it might work, sometimes it might not work. Okay, it might depend on the implementation. It might depend upon. The answer is not definite. That is because in this case, what happens is that the value of X is instantiated before we go and search for this negation clause.
yeah. So as you told earlier, it will create a problem because.
Yeah.
Okay.
Okay. Because the way we are implementing negation as failure is using the operator cut. All right. Let's try to understand what cut is, and then everything will be all right. Okay. So what is this cut operator? Bang. Okay. Bang is a special operator. It's a one-way gate. It's like a turnstile. It allows you to go only one way. That's what cut is. Okay. So the goal bang, pronounced cut, always succeeds immediately, just once. It cannot backtrack over it. What does that mean? That means it has an important side effect. Once it is satisfied, it disallows just for the current call to predicate containing the cut. Backtracking before the cut in that clause using next rules for this predicate. All right. So for instance, if I have a rule like P, B1, B2 bang, B1, B2 cut, A1, A2, A3, and P, R1 to Rn, and P more rules. Okay, so I have at least 3 rules for P here. 3 rules. But the first goal is B1, B2, then cut, then A1, A2, A3. In that case, what happens? So because we are trying to, if we are trying to prove P, we will take the first rule and we will try to satisfy that. Yeah, that's our algorithm. So if we manage to succeed in B1, then we will proceed to prove B2. If we manage to do that, then we prove cut. But cut always satisfies. But it has a side effect. What is the side effect? Once cut is satisfied, there is no more searching for rest of the rules. Okay, so if once cut is passed, it's like a one-way gate. So the only way this P can be proven is by proving A1, A2, A3. It cannot go back and try any of the rules. Okay. After reaching bank, no backtracking on B1 and B2.
Sir, in the max, the first definition that we discussed,
Yeah.
in which there was a problem, if we use max with this cut
Yeah.
everywhere, then it would work then, right? The first definition also.
It will work. Exactly. It will work. That's what we are going to see.
Okay.
So let me say what is bang cut once more. Cut actually is a one-way gate. So you can put it in any of the rules anywhere. The moment, so generally when you try to satisfy a rule, you try each rule. If it fails, you try the next rule and so on. With the bang, you can put it anywhere in the rule. But once that point is reached in trying to prove that rule, then no backtracking beyond that point will be done. You can only go forward. Okay, in trying to prove that rule. Okay. So, what is an example of cut? So let's try to do max using cut. So if I say max x, y, z, and if I say x less than y, then if I put a cut here and I say y equal to z, okay. Otherwise, I write max of x, y, z, and what should I write here?
X equal to Z.
X equal to z. Okay. So now this is correct because once I am x is less than y, then there is no way I can try to prove. I can try this rule x equal to z. So it will always succeed. No, sorry. Then that means that there is only one way in which x once you pass x less than y, there is only one possibility for z, that is y. You won't try x ever. Okay. So actually negate this slash plus implemented using cut. Okay. Slash plus is implemented using cut. So now let's yeah, so if I have P A arrow B slash C is same as what is it same as? P A cut B, otherwise P C. Yeah, that's what is this one. Because if I succeed with A, then there is only one possibility in front of me, which is trying to prove B. But if I fail to prove A, then I can just go on and try C. Okay. We can implement P arrow B comma B or C using cut. P if B A bang B C. Now fail is a special symbol that will immediately fail when prolog encounters it. We can implement negation as failure using cut and fail as follows. If I want to say that negation of a goal is nothing but goal cut fail. Okay, so that means that there is only one way I can try to succeed on goal, which is trying to fail. I mean, trying to fail on proving goal. Okay, so if I say goal bang fail, then if goal succeeds, then I terminate the program. Otherwise, I can take negation of goal to be true and then continue. Okay. I hope it is clear. I'll give you some exercises.
Sir, I have a
Yeah.
doubt.
Yeah.
So what happens if there's a recursive call on either side of cut? So then does it not execute that for that recursion, or lower down in the tree it will still allow to execute the latter statements?
So you are asking something like, if I have goal X, let's imagine goal X bar T, and then I have some thread X cut, and then goal T. Yeah, something like this.
Yes, sir. And one more goal statement after that.
Where? Here?
So after that, yes, sir. Not in another line. So or.
Goal something like this. Okay.
Yes, sir.
So in this case, I come here with my original list and I try something. If it succeeds, I move on to this rule. So that means that if this cut fails, if this predicate fails, then I can go and try the second possibility. Otherwise, I'll have to continue with this. Okay, there is a beautiful example. Let's imagine, it's a good question what you asked. Let's write intersect. Okay. Let's write this predicate intersect X L K is true if K is the restriction of L. Let's write K L J K. If K the restriction of L to J. So that means that if I have two lists intersect 1, 2, 3, 4, 5, 6. The first list is 1, 2, 3, 4, 5, 6. The second list is even numbers. Okay, 0, 2, 4, 6, 8. And the third list is the restriction of the first list to the second list. That means I can only take an element. If I take an element from here, it is in the last final list only if it is in the second list. So it will be 2, 4, 6. Is that clear what this predicate intersect is? Any questions about this predicate intersect? So how do I write this? So the intersect is K is nothing but intersection of the list L and J. Okay, that's what intersect is. So how do I write intersect? Intersects of X bar T1, J, X bar T2 if how do I write that?
Member of
Member
X comma J.
X comma J and I can put a bang here. Okay, because once X is in J, then it always must have to be in the last list. Okay, so there is no need to backtrack. Okay, bang intersect T1 T2 T1 J T2. Okay, otherwise intersect, and I don't care what is the first element, T1 J Is this correct? Is this correct? Devani?
So actually, I have a doubt. I don't know how it evaluates in this case. That's what my doubt is. Like for when it's doing T1 J T2, is it allowed to consider the second part?
No, see, so your question is what happens to X bar T2? Is that your question? What happens to X bar T2? If I encounter this bang, what happens to X bar T2? Is that the question?
So actually, my question is, I mean, I want to know how this is evaluating. I'm not able to understand because after the bang, the intersect T1 J T2 occurs. So
Yeah.
if it has to evaluate intersect T1 J T2, then since bang has occurred, it's not allowed to consider the second, that is intersect T1 J K.
Yeah. Since bang occurred here, it will not consider this rule at all. So it can only move forward.
Yes, sir. But then while proving intersect T1 J T2, also it's not allowed to use T1 J K.
No. While proving intersect T1 J T2, it's a separate goal.
Okay.
The bang occurs only for the current goal. Okay. So that's what it says here. Always succeed immediately, but just once. You cannot backtrack it. It has an important side effect. Once it is satisfied, it disallows just for the current call to predicate containing the cut.
Okay. Okay, sir.
Okay.
Yes, sir.
So that means that, okay, that's an important question what she asked. If I'm trying to prove intersect X bar T1, J X bar T2, and I encounter member Xj, then this bang occurs. And for this current call, I will not consider this. I can only move forward. But for this intersect T1, J, T2, it can again consider it is a fresh call to this one. Okay, so it can consider either this goal or this goal. Okay. Okay, that's what this one is. Intersect is. Yeah, and so I will stop with prologue. You know pretty much all of the constructs of prologue now. It's all this much. And prologue, there are several chat boards. That's a interesting project which you could do. You could write in not so many lines, chatbots using Prolog. Just have a look, search for Prolog chatbot and follow the first link. Okay, this is a code which you can understand. It's just basically pattern matching. So if you want to write a chatbot, for instance, recently I was setting up a Razorpay account for one of the conferences I'm organizing. So I had to chat with the Razorpay, this one. So they say that it is a customer care service member you are chatting with, but it's a chatbot. But basically, it's a very limited interaction, limited scenario interaction, where you're only talking about that particular transaction or registration or some configuration setting and so on. So you can easily write. There is an advantage which Prolog has over other programming languages, which is that here you can parse the sentence. You can dig into the sentence to find if there are words. For instance, if you see, most of this program is just list. For instance, responses db by. By is a constant which is attached to a list of lists called by. Hope to see you again. Have a nice day, and so on. And responses db of greeting is hello, hello, nice to meet you, hi there, welcome, good afternoon, hi. Responses db change topic is do you mind if I ask you more questions, and so on. Yeah, so it's a everything is a constant followed by a list of lists. Most of this program is like that. Okay. And what you're actually writing is you're actually writing rules about how to form sentences, how to find if a sentence is a question, how to answer such a question, how to generate, how to ask for dates, how to parse all these things. Yeah, so you can write simple rules. These are intersect, which we just wrote. Subset your item contains. So it's a pretty simple program. And so Prolog is a wonderful programming language. If you want to write such pattern based program where you have possibly hundreds, and in this case maybe tens of thousands of scenarios, and you can without much difficulty you can write rules which will mine you the relevant information, and you can write programs for dealing with those scenarios. Yeah, so that's why it is a good planning programming language where so far we have been using very mathematical kind of programs like intersect, reverse map, all these kind of things, but the power of Prolog comes more like in scenarios like this where you have to pattern match. Yeah, and this idea of Prolog pattern matching is there in many programming languages, but the idea of unification is only there in Prolog. Yeah, every other programming language, it is based on input output. You specify what are the inputs, you specify what is output. In Prolog, there is no such distinction. You specify a set of parameters, and Prolog takes those parameters for which the rule succeeds. Okay. So in some scenarios, what comes as input could be output in some other scenarios. All right. Any questions? Any questions? All right. So then I will stop with Prolog. We'll have a quiz on Wednesday. And next week onwards, I will start with C++. Okay. Thank you. Thank you.
Thank you, sir.